Good morning dear students. In your previous video class, you learnt about the chemical properties of metals. Under that heading, how metals are react with air, you learnt already. And how metals are react with the water, what happened when metals react with acids. And from all those concepts, we come to the conclusion, metals reactivities is varied. It is different from one another. And also, we learn more about the reactivity by taking another one concept, that is metals react with the solutions of other metal salts. From this also we go to clear understanding of the reactivity of the metals. Okay children, see now this is the general form of the equation. Metal A reacts with the salt solution of the B. It gives the product like this, salt solution of A and metal B. Now, understanding it by taking the example here, iron as a metal and salt solution as a copper sulfate. It gives the product FeSO4 and the metal B. Observe children here, iron reacts with the copper sulfate solution. It produces ferrous sulfate solution and with copper as a metal. Here we observe one thing, iron is a metal and copper is also a metal. But iron takes the place here and the copper comes out. Is it or not children here? Yes. Iron takes the position of copper. The copper is coming from the solution, salt solution. And here iron is more stronger. We clearly understanding here, iron is more stronger than the copper. Because of that reason only, it displaces copper from the solution and it takes the position here. Okay. Here in this way, the which metal is stronger than the other, it displaces the position in that solution or in that salt solution. Yes, you already learned about this in your previous chapter. This is an example for displacement reaction. This is an example for displacement reaction. Children, look at this picture. This is having two test tubes, A and B. This picture shows reaction of metals with salt solution. Yes, in test tube A, the copper sulfate solution is taken and iron nile is thread. And in the test tube B, as we see iron sulfate solution and copper wire that looks like a copper wire. As all of you observe the test tube A. As in the test tube A, basically we take copper sulfate solution and iron nile is dipped in that test tube. After some times the solution color gets changes and also iron nile color is changes, that is shown in the test tube B. Look at the solution. Yes, the solution become colorless or it fade the blue color and iron nile color gets changes to orange red. From this reaction we come to the conclusion like this. The copper is displaces from the iron to become ferrous sulfate solution or iron solution and copper is displaces on the iron nile. Dear students, up to now we are discussing about chemical properties of metals. Under the heading, we learned how metals react with air, how metals react with water, how metals react with acid, and also the metal reacts with the salt solution of other metal. From all the concepts, we come to the conclusion, the metals reactivity is different from one another and the metals reactivities are arranged in a series. That series is known as the reactivity series of the metals. Look at children, this is a reactivity series of the put first place of this series. These two are known as more reactive metals. More reactive metals. Now come to the calcium, magnesium, aluminium and zinc. These are metals are called as moderately reactive. That means middle reactive metals. Moderate reactive series metals. Next, come to the iron and lead. They are moderate reactive. Compared to these are lesser reactive and weakly react with the other air, water and others. And next we come to here copper, mercury, silver and gold. These metals are very less reactive metals. Listen once again children. Potassium and sodium are more reactive metals. Calcium, magnesium, aluminium, zinc. They are moderately reactive metals. As iron, lead and hydrogen. Hydrogen is a non-metal. For that reason here put the square bracket. Among those that shows metallic property. As for that reason this is taken in reactivity series. Iron, lead and hydrogen are moderately reactive. Compared to these, they are very less reactive. Come to here copper, mercury, silver and gold. These are very less reactive metals. Okay children. Now let's come to your in-text question of your textbook. In-text question of the page number 46. Here the first question is like this. Why is sodium kept immersed to kerosene oil? Yes, why sodium is preserved in kerosene? Our question is why sodium is preserved in kerosene? Children, you know that, observe here, sodium is more reactive metal. For that reason, that is preserved in kerosene, that is kept in kerosene. Because sodium highly react with air and they are also react with water to produce hydrogen gas, and the reaction is more vigorous and sometimes it catches the fire also. Because of that reason, sodium is preserved in kerosene. And the next question is, write equation for the is iron with steam. Second question. In the second question, sub question is iron reacts with steam. Yes, iron reacts with steam. See here. Iron reacts with water, that means steam. It produces iron oxide Fe2O3 with liberation of hydrogen gas. Yes children, now let us go to balance this equation. Put here 2. Now count oxygen first. 2 3s are 6 atoms are there in right hand side. Now let us go to balance oxygen on the left hand side. Observe here how much oxygen atoms are there? Only 1. So put here 6. Is that become how much here? Oxygen is balanced. But come to the hydrogen gas, 6 tubes are how much here? 12. Yes, now let us go to balance here. Yes, that becomes 6 tubes are 12. Now come to the iron. Iron is how much here? 2 tubes are 4. Now put 4 in front of the iron. Yes. Now this is a balanced chemical equation. Okay. Next question is calcium and potassium with water. Second sub question is calcium and potassium with water. potassium oxide. CaOH twice plus hydrogen gas. Hydrogen gas is given. Yes, now let us observe the atoms are balanced on both the sides. First we come to here. Oxygen is how much here? 2. Here oxygen is only 1. Let's put here 2. Now let's count hydrogen. 2 2s are 4 here. On the right hand side, 2 plus 2, 4. Yes, that is balanced. Here calcium is only 1 atom. Here calcium is only 1. This is balanced by the equation. Next, we come to the potassium. Potassium is chemically represented by this K, chemical symbol of potassium. Let's react with the water to produce this CaOH with liberation of nitrogen gas. And observe here the balance of the equation. Now, from here hydrogen is 1, here 2. 2 plus 1 becomes 3. Yes, for that reason put here 2. 2 hydrogen plus 2 hydrogen becomes 4. Let's put 2 on the left hand side. Now hydrogen gets balanced. Next, come to oxygen. Oxygen atoms are 2 on the left hand side. Now here also 2 on the right hand side. Oxygen. Yes, observe potassium. Potassium is 2 on the right hand side. So put here 2 on the left hand side. Yes, this is now balanced chemical equation. Yes, all of you write answer to the second question. Okay.
Yes, look at children. Third question is like this. Samples of 4 metals A, B, C and D were taken and added to the following solution one by one. The results obtained have been tabulated as follows. Look at children, the table. Table is having 4 columns and 4 rows. Yes, metals is the first column. Metals are named as A, B, C and D. Yes, second column, the solution is iron sulfate. Third column solution is copper sulfate. Fourth column is a zinc sulfate. The fifth column is silver nitrate. And some observations are tabulated in the table. Yes, look at those. And now let's see questions which are asked based on their table. Use the table above and answer the following questions about metals A, B, C and D. Okay. Now come to first question children here. Which is the most reactive metal? Yes, I already put here the answer B. Now let's discuss about how B is possible. Which is the most reactive metal? Yes, look at the table children. Here displace, that word, displacement word we seen at the column iron sulfate first. In next column copper, zinc sulfate there is no displacement word, and silver nitrate the next. Yes, from this displacement the word is we seen at iron sulfate, that is belongs to B metal. Yes, B displaces iron sulfate, iron from the iron sulfate. Yes, okay children, B is the metal that displaces the iron from the iron sulfate solution. For that reason B is a very reactive metal. Second question, what would you observe if B is added to a solution of copper sulfate? Yes, look at children, B, row, and what is asking here? Copper sulfate. Yes, where is that copper sulfate? Yes, when B is added to the solution of copper sulfate, B displaces copper from the solution. Yes, B displaces copper from the solution because B is very reactive metal that displaces iron. That is displaces iron and also that it displaces the copper, zinc and silver. Because of that reason, B displaces copper from the solution. And third question, arrange the metals A, B, C and D in the order of decreasing reactivity. Yes, first we write here strong metal. Next, the reactivity series goes on decreases. See children, B displacement word we seen at the column second, and that is for only B. So B is stronger. Next, displacement word is seen at the third column for A. A is next stronger metal. Yes, the next one is last column we seen displacement word for the C. Yes, C is next coming metal. The last one, that is remaining one is D, that is very weaker metal. In that way, the reactivity goes on decreases like that, B, A, C, D.
Children, now come to fourth index question. Fourth index question is like this. Which gas is produced when the dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction when iron reacts with dilute sulfuric acid. Here, the production of gas is hydrogen. Hydrogen gas is produced. And second half question is, which chemical reaction takes place when iron reacts with the sulfuric acid, H2SO4. The product becomes FeSO4 and with the liberation of hydrogen gas. Children, we already discussed the metals reacts with any dilute acids, it produces hydrogen gas. See now, iron reacts with the sulfuric acid, it produces ferrous sulfate and hydrogen gas. Now let's check whether the equation is balanced or not. Iron is 1, here also iron is 1. Hydrogen is 2 atoms, here hydrogen is 2. SSO4, iron is 1, here also SSO4 iron is 1. Yes, this is a balanced chemical equation. Next, now come to the fifth question. Fifth question is, what will you observe when the zinc is added to a solution of iron sulfate? Write the chemical reaction that takes place. Yes, zinc reacts with the iron sulfate solution. Zinc is a metal, reacts with the iron sulfate. This is also a solution of metal. What happened here? Observe here, zinc reacts with the ferrous sulfate solution or iron sulfate solution. It produces zinc sulfate and iron comes out. Look at children, zinc displaces iron from the solution to form zinc sulfate and iron gets out. This is a chemical reaction takes place. This is an example for displacement reaction, and from this answer we come to the conclusion the stronger metal displaces the weaker metal from the solution. All of you write the answer to the fourth question and fifth question now. Okay children, now let's come to study about how metals react with non-metals. Reaction of metals with non-metals. Reaction of metals with non-metals is, all of you look at the table. Yes, that shows electronic configuration of some elements. This is very enough to know about the electronic configuration of metals and non-metals, to understand how metals react with non-metals. Okay children, yes, look at this table. This table is having respectively 2, 10 and 18. And observe the number of electrons in the shells, K shell, L shell and M shell, respectively helium, neon and argon. Look at the children. Here all are completely filled. All are completely filled, and because of that reason they are known as noble gases. They doesn't involve in any chemical reaction because of their no valency, and those elements doesn't give up their valence electrons. And next come to the second rule, metals. Under the heading, here sodium, magnesium, aluminium, potassium and calcium are given, and respectively their number of electrons in the shells is given. Sodium is only 1 electron in M, magnesium is 2, aluminium is 3. Come to potassium and calcium, respectively 1 and 2. Observe there 1, 2, 3 and 1, 2. From this we conclude here, outermost electrons are called as valence electrons, and those valence electrons are the responsible for their chemical reaction. Here the possible case is these electrons are given up by the metal to obey the octet structure. Take one example from the metal column, that is sodium, how it becomes electropositive. Okay, metal sodium, that is chemical symbol is Na and the atomic number is 11. From that we write electronic configuration 1s2, 2s2, 2p6, 3s1. Yes, first shell is having 2 electrons, second shell is having 8 electrons, third shell is having only 1 electron. Look at children, here sodium is having 2 cases to obey the octet structure, 2 possibilities. Yes, that's known as possible situation. One is it gives up their 1 electron to become an octet. Otherwise, it receives 7 electrons from other atom of the element or metal to become an octet structure. Here, which is very easy. Yes, give up their 1 electron is very easy. Yes, for that reason, sodium atom give up their 1 electron from it to become electropositive. How it become electropositive? Yes, look at here. Sodium is having 11 protons and 11 electrons in the atom. 11 electrons are revolve around the nucleus with particular orbit, and protons are between them. And here 1 electron is given from this. 1 electron comes out. Now the electron become 10, but protons are 11. Protons are 11. Because of this reason, it becomes electropositive. Positive character in an atom is increases compared to the electron. That means negative charge. Because of that reason, that is known as electropositive. Some here observe, here it gives only 1 electron, it represented by only +1 or plus. Sometimes some other metals give their 2 electrons, they are shown by Na plus 2 or 2 plus like that. How much electrons are go out or give up from the atom of the metal, that is shown by the number. Yes, children, all metals are electropositive. This is because the valence electrons are 1, they are magnetic, or they are filled up by the valence electrons 1, 2, 3. As the possible cases of all the numbers to become an octet is give up. Give up is only the possible situation to become an octet structure. For that reason, all the metals are having to show the positive character to become electron positive. Now come to the non-metals. In the column, we take one of the example, oxygen. Oxygen is atomic Like this possibilities, all non-metals are shows electronegative character in chemical reactions. Okay children, all of you write this information. This is very useful when we will discuss about how metals react with non-metals. Let's now come to how metals react with non-metals. Take example for metal is sodium. For the non-metal is chlorine. Okay children. Sodium atomic number is 11. According to the electronic configuration, 1s2, 2s2, 2p6, 3s1. First electron 2, second shell is having 8 electron, third shell is 1. In the same way, write electronic configuration to chlorine. Chlorine is having 70 atomic number. According to that electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. First shell 2 electrons, second shell 8 electrons, third shell how much electrons are there? S, 7 electrons. S, here sodium atom give up their one electron to become electropositive. And chlorine atom it receive one electron from this to become electronegative. Look at children, sodium give up their one electron to become electropositive, and chlorine it receive one electron from this sodium to become chlorine negative. S, sodium atom put one electron, that is shown by the star mark like this, plus chlorine. Chlorine is having how many valence electrons? It's 7 valence electrons that are shown by like this 1, 2, 3, 4, 5, 6, 7. There is a vacant place here. Assume like that there is a vacant place in chlorine. That vacant place is filled up by the sodium to become NaCl. Here sodium is positively charactered atom, that means a metal. Chlorine is negatively charged non-metal. Both are attracted by the oppositely charged ions Na plus and Cl minus. Both are held together by the oppositely charged atoms. Both are held together by the oppositely charged atoms. That kind of force of attraction is known as electrostatic force. Electrostatic force. Oppositely charged ions are attracted and held by the force. That force is known as electrostatic force. Electrostatic force is very strongest force and it forms an ionic bond. Here electrons are transferred and one of the atom is it received. Electron give up and taking processing takes place. This kind of reactions takes place in chemical reaction and the bond is known as ionic bond. In the reaction of metals and non-metals, that takes only the ionic bond. Metals react with the non-metals. The compound is formed. In the compound, the ionic bond is formed and the compound is known as ionic compounds. Ionic compounds. All of you take this notes now.
Children, till now we are discussed about how metals react with salt solution of other metal, reactivity series of the metals, and metals react with non-metals. I hope that all of you understood very well. We will discuss the remaining concept of this chapter in your next class. Thank you.